Let's learn a chapter probability in which let's study probability in which we are going to introduce with few terms like random experiment and its outcomes, sample space and event, probability of an event. Let's learn all these one by one. Number 1, random experiment. The experiment in which all possible results are known in advance but none of them can be predicted with certainty and there is equal possibility for each result is known as a random experiment. For example, tossing a coin. Throwing a die, picking a card from a set of cards bearing numbers from 1 to 50, picking a card from a pack of well shuffled playing cards, etc. Number 2, outcome. Results of a random experiment is known as an outcome. Example, in a random experiment of tossing a coin, there are only two outcomes, head or tail. In a random experiment of throwing a die, there are 6 outcomes according to the numbers of dots on the 6 faces of the die. 1 or 2 or 3 or 4 or 5 or 6. 1 or 2 or 3 or 4 or 5 or 6. In a random experiment of picking a card bearing numbers from 1 to 50, there are 50 outcomes. A card is drawn randomly from a pack of well shuffled playing cards. There are 52 cards in a pack as shown below. Total cards 52. 26 red cards, 26 black cards. In those 13 heart cards, 13 diamond cards, and in 26 of black cards there are 13 club cards, 13 spade cards. In a pack of playing cards there are 4 sets, namely heart, diamond, club and spade. Heart, diamond, club and spade. In each set there are 13 cards as king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 and ace. King, queen and jack are known as face cards. In each pack of cards there are 4 cards of king, 4 cards of queen and 4 cards of jack. Thus total face cards are 12. Okay, here ace of spade, ace of heart, ace of club, ace of diamond. Number 3, equally likely outcomes. If a die is thrown, any of the numbers from 1, 2, 3, 4, 5, 6 may appear on the upper face. It means that each number is equally likely to occur. However, if a die is so formed that a particular face come up most often, then that die is biased. In this case, the outcomes are not likely to occur equally. Here, we assume that objects used for random experiments are fair and unbiased. A given number of outcomes are said to be equally likely if none of them occurs in a preference to others. For example, if a coin is tossed, possibilities of getting head or tail are equal. A die having numbers from 1 to 6 on its different faces is thrown. Okay, check the possibilities of getting one of the numbers. Here all the outcomes are equally likely. Number 4, sample space. The set of all possible outcomes of a random experiment is called the sample space. It is denoted by capital S or omega, a Greek letter omega. Each element of sample space is called a sample point. The number of elements in the set S is denoted by n of S. If n of S is finite, then the sample space is said to be a finite sample space. Following are some examples of finite sample spaces. Number 1. Random experiment, one coin is tossed. S, that is sample space, is a set of H comma T. Okay, it should be in curly bracket. Number of sample points in S, 1, 2. That's why n of S equal to 2. Second experiment, two coins are tossed. Sample space S is a set of HH or HT or TH or TT. That's why S is a set of HH, ST, TH, TT. There are 1, 2, 3, 4 elements. That's why n of S equals 4. Similarly, if 3 coins are tossed, then sample space S equals a set of HHH, HHT, HTH, THH, HTT, THT, TTH, TTT. Means there are 1, 2, 3, 4, 5, 6, 7, 8 elements in this set. That's why n of S equal to 8. Next experiment, a die is thrown. S is a set of 1, 2, 3, 4, 5, 6. Therefore, n of S equals 6. Next experiment, two dice are thrown. S is a set of 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 1, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Means there are 6 by 6 means 36 elements. Therefore, n of S equals 36. The next experiment, a card is drawn from a pack bearing numbers from 1 to 25. Therefore, S is a set of 1, 2, 3, 4, so on up to 25. Therefore, n of S equals 25. Next experiment, a card is drawn from a well shuffled pack of 52 playing cards. There are in a diamond, there are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10 and Jack, Queen, King. Okay. Also in a spade, there are Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. In heart cards, Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Similarly, in club cards, there will be Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. Means 13 fours are 52 cards. Therefore, N of S equals 52. Let's remember, the sample space for a coin tossed twice is the same as that of two coins tossed simultaneously. The same is true for three coins. Next, the sample space for a die rolled twice is the same as two dice rolled simultaneously. Number 5. Event. The outcomes satisfying particular condition are called favorable outcomes. A set of favorable outcomes of a given sample space is an event. Event is a subset of the sample space. Events are generally denoted by capital letters A, B, C, D, etc. For example, if two coins are tossed and A is the event of getting at least one tail, then the favorable outcomes are as follows. A is a set of TT, TH, HT. The number of elements in the event A is denoted by N of A. Here N of A equals 1, 2, 3. That's why N of A equal to 3. For more information, types of events are certain event or sure event, impossible event, simple or elementary event, complement of an event, mutually exclusive events, exhaustive event. Number 6. Let's learn probability of an event. Let us think of a simple experiment. A bag contains 4 balls of the same size. 3 of them are white and the 4th is black. You are supposed to pick one ball at random without seeing it. Then obviously possibility of getting a white ball is more. Okay. In mathematical language, when possibility of an expected event is expressed in number, it is called probability. It is expressed as a fraction or percentage using the following formula. For a random experiment, if a sample space is S and A is an expected event, then probability of A is P of A. It is given by following formula. P of A equals number of sample points in event A upon number of sample points in a sample space, that equals N of A upon N of S. Therefore, P of A equals N of A upon N of S. In the above experiment, getting a white ball is event A. As there are 3 white balls, N of A equal to 3. As the number of balls is 4, therefore N of S equal to 4. Therefore, probability of getting a white ball is P of A equals N of A upon N of S equals 3 upon 4. Similarly, if getting black ball is event B, then N of B equal to 1. Therefore, P of B equals N of B upon N of S equals 1 upon 4. Let's remember, the probability is expressed as a fraction or a percentage. The probability of any event is from 0 to 1 or 0% to 100%. If E is any event, then 0 is less than or equal to P of E is less than or equal to 1, or 0% is less than or equal to P of E is less than or equal to 100%. Example, probability 1 by 4 is written as 25%.